everyone. This is Professor Tariq Al-Taib. In this video, we're going to talk about supporting processor upgrading memory, okay? So, part of the A plus course. So, objective in this video, in this course, or in this chapter, we need to comparing between some characteristics and proper purpose between Intel and AMD processors uh, for using personal computer, then how we can upgrade and install the processor. Then we compare the different kind of the physical memory actually and how it works and how if I need to upgrade memory, what should I do, how progress I can do that. Okay, so let's go. So the processor characteristics here, the processor, we have a two type of processor. So processor installed, first of all, we need to know the processor installed obviously in the motherboard. And the processor they determine the system computing power. Computing power meaning the performance, if my computer is high speed, computer, what you doing with the games, stuff like that. So we have two major of brands of processor, Intel and AMD. So the facility for performancing or the things that make affecting and the performance processor with the motherboard. For example, processor speed. So what the processor speed of this CPU or the processor, all right? Core 1, Core 2, Core 3, Core 5, Core 6. I think in the market now we have a Core 9. So we have a Core 7 and coming also Core 9. Socket and chipset the processor can use. So the processor architecture is consisting of should have a multi-processing ability. Multi-processing ability meaning you can running multi-application. In the application, we have a multi-threading and multi-core processing and dual processor. All right, so let us go to see each one from those terminology. So also the things that affecting the processor memory or processor performance, compatibility with the motherboard. Sometimes the processor core 5, but the motherboard doesn't support core 5. So this is very important. Or the processor work with 64 data bus, but the processor work with the 32. The motherboard, sorry, work with the 32. So the conflict or vice versa, by the way. So this is affecting. Also the memory cache. The memory, every processor chip, the processor itself, it consists of the memory. It comes with the memory. So the memory, including the inside the processor, we call cache memory. So it could be 125, 64, 255, 6 kilobytes, by the way, or sorry, megabyte. So security, the security of the processor, meaning how the processor can receiving information from different devices, because we know the processor receiving most of the processing information from the RAM. But what if they come some data from the dual cards? Memory features in the motherboard that processor can support, like for example, what if the processor doesn't support HDMI ports? So this could be all processor, Also support virtualization. Virtualization, it is a new technique. We spoke about it in the different previous different chapters. And as we go, we can mention those virtualizations. So virtualizations should be supported by microprocessor, because sometimes we installed virtualizations, but the processor doesn't support virtualization, because virtualization is virtual computer. So inside your computer, you're gonna put other computers. You're gonna create another computer. So what if this computer, maybe for example, your computer Windows, you can create Mac and Linux and another Windows server, for example. You have a 3 virtual machine. So every computer, as your computer right now, it needs resources like you need the CPU, need part of memory, stuff like that. So sometimes the processor doesn't support virtualization. Integrated graphics. Integrated graphics, it's a graphics card or graphics um, the graphic adapter that we can see something in the screen. We call graphics. So integrated graphics here. What if my motherboard coming with integrated graphics. So meaning the graphic is not separate, is not adapter. So that's mean we need assign some processor um, resources and the memory resources to this card. So is this processor, it has this ability, providing this ability and or not? So basic component in the processor, we have input output, we have a control unit, and we have something ALY, which is arithmetic logic unit, which is very important part for the computer. So input output, you know, every data come through computers. We have the data input output. So in the basic computer diagrams, computer diagram consists of input data, then processing, then output results. If you remember this architecture. So how the processor manage this data instructions, entering and leaving processor. Control unit manage all activity inside the processor. For example, if the data move from RAM to the CPU and then gone back to the from CPU to the RAM, then again this same data return back to the RAM, CPU or processor, then later after finish processing return to hard drive. How we control, how manage all this activity by a processor. Then the end, all the processing, like if you, whatever you see in the computers, games, applications, your operating system, in the end will be translated to the basic um, equations, those kind of things. So whatever you see complex stuff, in the end will be as a arithmetic and logic unit, meaning multiplication, addition, division, subtractions, and logic meaning greater than, less than, equal, stuff like that. So this is the basic component in the processor. Registers. Register is small holding area on processor chip. So in register, it's a small piece of memory. Sometimes you call it buffer. So it's hold counters, data, instruction, and addresses ALU in the current processing. So internal memory caching, we have L1, L2, L3. Internal memory L1, L2, L3. Hold the data and instruction to proceed by ALU. Buses connect component with the processor. So buses is the lines that where the data transfer from the hardware. The buses, okay. Um, Now, in this diagram, we have seen, for example, see this golden stuff is buses between the different components um, and this motherboard. So this is will be input output unit. This is the Pentium processor, by the way. It's one old style fashion, but um, um, CPU or processor. So this inside the CPU itself, we have a registers, which is kind of buffers, and we have a control unit, and we have an internal memory cache. We can, because sometimes, and we have input output unit, and we have an ALU inside. This is show you is 32-bit, for example, in this case. It was in this technology, it wasn't have a 64. The maximum it was 32-bit. So this one it released in 1993. And it was success CPU. However, how processor works? So the processor has a frequency, speed which a processor operates internally. Multi player or multiplayer factor multiplied against system bus frequency determine processor frequency. So the data and the information between the CPU component will be transferred based on time. And this time will not hour, second, or millisecond time. It is like a frequency of the CPU. Multiplier is factor multiplied against the system bus frequency, which determine processor frequency. For example, if system bus frequency times multiplier give us the processor uh, frequency. So system bus frequency, the bus, because how we can determine the speed of the CPU by multiply those things, system bus frequency times multiplier. So multiplier how the speed the data go through the do the data bus. So for example, if data bus go from this component to this component in 1 millisecond or 3 millisecond. So the data go with the 3 millisecond from this component to the CPU. So this would be the delay coming out of control of the CPU processor. So system bus frequency times multiplier give us the processor frequency. So processors sold today continues all ALUs registers that can process 32-bit or 64-bit at a time. So three category of processor, 32 processor, which is we known as a 86 or x86 can handle 32 instructions for operating system. You need to know this 86 because if you found 86 and any hardware, then you know you will know this 32 processor hybrid processor known as 86 or x86-64, which is also if 64 can handle 32 or 64. AMD also produced the first one called AMD 64. 64 processor known as a 64 processor or IA64 requires 64-bit operating system can handle 32 application only simulating 32 processing. So all those how processor information you don't know. Memory cache, we have a L1, L2, and L3. So memory cache here, each core in a processor has its own L1 or L2 cache. We're meaning like a low or like a location 1 and location 2. All cores maybe share another location 3 cache memory, which is providing some extra addition memory to improve the performance. So memory controller include the processor package. So processor package meaning here, when you send the data to processing, this data could be part of the application, part of the application. So we're gonna explain this in following lectures. So when you, for example, I open Microsoft Word. Microsoft Word maybe have a 100K as a coding behind the scene, you know. So the coding will be include the processor package, significantly increasing in system performance. So the controller that's we need it when data be ready sometimes to go to the CPU or data go will not sending the data CPU till we have memory locations available. This is called memory controller. Memory controller gonna control the processor package and they say, for example, when you open Microsoft Word, will not all the code go over there in the memory. We're gonna go to certain code, certain part of the application go to the CPU, significantly increasing the system performance. So this is the core one, core two, core three, core four, and every core has a cache memory, and they are sharing with the uh, um, another location or level of the cache. So every core has its own cache and extra cache L2 and L3 will be um, for sharing cache between if this core one that cache 2 is not enough, we have this third cache memory. So this is the speed, for example, core 7 up 3.8 and core make it bigger. There you go. Core 5, 3.6 gigahertz. Fourth generation. This is the fifth generation. Core 7, 4.4, which is 8 mega cache memory, you know. This is different brand, you know. This is like a Haswell, and this is Broadwell. And for example, Core 7 here, 3.9 and core 5 here 3.8. So this is different brand, and um, that will be good table to take a look. Oops. We go to next slide. Oops. Okay, the PowerPoint doesn't work. I'm gonna stop in this part. I'm gonna create another video. See you next video.